Hi, I'm Phil, and I work for NCR Edinburgh. One of the things I really enjoy working for them is getting 10 kind of study days a year where we can kind of study anything we want. We're hiring at the moment, and so talk to me if you're interested. And this is my wife.
Hi, I'm Lelen. I'm a web and graphic designer, and I'm working for a startup company in designing web and iOS apps.
At the Audio Hack Day, I was speaking to one of my previous colleagues, Dan, who won the hackathon, and he said, what are you speaking on? I said, I'm working on some lyric software for displaying lyrics on kind of mobile phones and different screens and things like that. He said, oh, I seem to remember that when I knew you 3 years ago, you were working on that. And so this has been a side project, it's been ongoing for a long time. And so this is the background to it. I'm a Christian and I go to church, and churches were one of the earliest adopters of kind of projectors, and they use them for projecting song lyrics in the services, and that works something like this. You have the band on the stage and the song lyrics come up on the screen like that, and then you have other screens on pillars where things are obscured. But the software that they use normally costs about £300 or something like that, and it's not applicable for every situation. So most churches have kind of midweek meetings, home groups, where they'll also probably have worship and things like that. And you see in this photo that people have got kind of the lyrics on printed out pieces of paper, and they're not going to pay £300 for that kind of software. At Easter, we went to an event in the Usher Hall. Again, it had sort of, I can't remember how many people, but over 1,000 people there. And we were quite late in booking, so we were seated up in the top. And they had lyrics on the screen, and every time they'd say, stand up to sing, the lighting rig would be in the way of the screen, so we couldn't see anything. And so everyone on the top row wasn't really singing the right words. And then if you have a huge event like this, well, where are you going to put the screens? And so the solution that I've sort of come up with is to render lyrics in a browser. And this means that you can display them on mobile phones, and you could display them on TVs using Chromecast, and you could display them through projectors having a full screen browser. And then you can control the lyrics by either using a laptop or a mobile phone just to control which verse and which song is being played. But there are lots of issues when we try and do this, and that's that all these devices have very different resolutions. So some people are starting to get 4K screens in their homes and Ultra HD. Then right at the other end of the spectrum, you have kind of old Android devices where they're kind of 320 pixels and whatever. And so it's quite tough to target these different screen sizes. Then we've got issues like device pixel ratio. Some devices have a 1-to-1 pixel ratio, most laptops, and then you've got things like iPads and iPhones, which have 2 device pixels, or 4 device pixels for every CSS pixel on the unit, and that gives us some challenges as well. Then we've got different orientations, portrait and landscape. And if we're looking at rendering text in a browser, we've got basically 4 different candidates. We've got DOM, basically HTML, rendering things in divs. We've got Canvas, using pixels, SVG, scalable vector graphics, and WebGL, which we just had a talk on just now. And so let's try and measure up these candidates. We're going to have to be measuring text, so we'll see how each of them does when it comes to measuring text. So this is our first candidate, and this is the DOM. And what I've done is I've basically put an absolutely positioned element there, and I've put some text in it, and that makes the boundary of the div kind of wrap around the element, and then I can use get bounding client rect to get the size of that div. But it doesn't give us a very good measurement because we've got all this space above the tops of the L, we've got all this gap on the left, a bit on the bottom, and a bit on the right. So let's see how SVG does. SVG seemed encouraging by the functions it provided. So it had a get computed text length that you could do on a text node in SVG. But again, the kind of red box around the edge represents when I try and measure the bounds of each thing. So when I try to measure the bounds of this, you can see that again it's got this gap on the right and on the left, and this one doesn't give me any height. And SVG again has a kind of a get bounding box function, and I was hoping that that would tightly wrap the curves of the text, but no, it kind of gives us the box that wraps the kind of line height and where maybe the next character should come if I was typing another character in. I was hoping Canvas might do something different, but actually it does pretty much the same thing. So it's got a function called measure text, and you can do that on the context of a canvas. And so here I've set the font height to be 200 pixels, and then I can measure the size of a string, and it returns an object, and from that you can get the width, but you can see it's not the width we're really looking for. And you'd sort of expect that if it returned a width, it might also return a height, but no, it's an object with a width in it. So it was great doing that web audio and seeing that we can analyze the spectrum of everything, get all these measurements out. When it comes to fonts, we don't have much, but maybe WebGL will save us. Well, it turns out that WebGL doesn't really know what text is, and so we can't really measure anything with it. Lelen is going to speak a bit about font metrics.
Right. So I'm going to introduce some basics about typography. And we start with baseline. Baseline is the line the text sits on. Then we got X height. X height is the height of the lowercase letters, except ascenders and descenders. So ascenders are the letters that have parts go above X height, and the descenders are the letters that have parts go below the baseline.
Okay, so we're going to try and measure our own, rule our own measure text function, and we'll do that using Canvas. And so the basic way that we're going to do it is to draw white text on a black background, and then our algorithm is going to basically snake down through the pixels, going down like this, until it hits a white pixel, and that's going to give us the offset of the top of the T, and then we'll snake up from the bottom, going across like this until we hit the first white pixel, which is at the bottom of that T there, and that will give us the offset to the bottom. We do the same from the left and the same from the right, and this is sort of what this looks like in code. So here I've got a canvas, and as I write text in there, it's measuring the width. You can see the width of that string is 403 pixels. The height of it is 147. It's actually got a slight descent. So this is the baseline here, the corner of this H, but you can see the O actually comes down below it. And so often things go slightly often to the left or slightly below where you think the starting position is. And if I wanted to measure a descender, I could put a G in there, and it gives me the descent of this font. And if I wanted to do the X height, I could just put an X in, and that would give me the X height, 104 pixels again. So using Canvas gives us an additional problem. If we were using SVG or if we were using DOM, it would have worked really nicely on retina displays, iPhones, and those kind of things. But Canvas, because it's using pixels, as soon as we put it on an iPhone, it's actually going to look slightly blocky because it's got four device pixels for every one CSS pixel. But we can use a function like this to actually scale down our canvas on an iPhone. So the basic algorithm is that we take the device pixel ratios, and on the canvas, if it was an iPhone, we'd want to set the canvas width to be double the screen size, and then we'd want to set the canvas style width to be the actual screen size. And that kind of, it will shrink it down, and you'll get a really crisp display on a retina or high DPI display. And so this is what happens when we measure a verse or something like that, and we try and display it on a device. And so here I've got a portrait and a landscape layout, and you can see that the landscape layout actually works sort of okay, that we've got a fairly good coverage on here. But on the portrait one, it's only kind of giving us about 15% coverage. So we're not using the screen very well. If there were several people looking at one display, they wouldn't be able to see it. And there's also some other problems with readability.
So there are some typography rules. If you decrease the font size, you have to increase the line spacing to make it easier to read. Also, if a line is too long and the audience tend to read the line twice, it's called doubling. And so you have to increase the line spacing to solve the problem. But in few cases, even increase the line spacing, it wouldn't work very well.
Okay, so what I was trying to aim to do at first was to try and get maximum coverage. And in order to do this, we need to kind of intelligently break lines. And I didn't want to use standard kind of line wrapping that you get in DOM, because that tends to give you kind of one word left over on the next line if a line is too long. So you get these orphans and the line lengths are not very even length. So I tried to come up with a way of breaking lines so that their length was as even as possible. And this was actually more difficult than it seemed at first. My first idea for an algorithm was that just you'd take your string, measure the length of it, find out if we wanted to break this into 3, we'd work out where 1/3 is and 2/3, and if a word was kind of more than halfway on that division thing, then that dividing line, then it would stay on the same line. If it was less, then it would carry over to the next line. But actually, it doesn't work very well, because you can see that in this example, this rendering is shorter than this one. And so, in the end, I kind of discovered that the only way that you can break lines and get them as even as possible is probably to try every permutation and combination of breaking them and evaluate which is the best one. And so this is sort of what it looks like when we do this. So I had a Google for election tweets, and this is one that I found. And so I'm going to copy that and put it in here. And so here it's kind of running through all the permutations. Actually, some of these have wrapped because they're of browser wrapping, so I'll try and get rid of that effect. And if I scroll down, I should find one which is kind of highlighted in red, which is the one which it's evaluated to be the best fit. Okay, so here it is. So here's a rendering, and so you can imagine that this would be quite useful if you're a company that kind of has tweets which are displayed on wallboards. Then this could exactly get it to sort of fit the aspect ratio of your display. Okay, but this is still not great for readability in this case.
So there's another typography rule you may find helpful. So if you break the line too short, it breaks up the phrases. And if a line is too long, it's called doubling. So as a designer, we normally tend to keep a line have between 35 and 70 characters. It's most comfortable way to read. But for lyrics, normally have quite short phrases, so it may not apply the rule here.
Okay, so probably the best thing to do with song lyrics is, because the portrait never works very well, is probably just display the whole song when the device is in portrait mode. And that's at least useful. So the next challenge is to find the best layout for verses. And this is the sort of algorithm that I've come up with for doing that. It's kind of a lookup-based one. So first of all, we write out the whole verse without any line breaks, and we measure the aspect ratio. We'll do this in, say, a 20-pixel font or something like that. Then we break the longest line as close to the middle as we can, and then we repeat this process until we have about 20 lines in that verse, because we know we're never going to want to use more than 20 lines or something like that. Then we measure the screen aspect ratio, and we might do this on a lookup on an on-resize event or something like that, on an on-resize event. And then we can look up the verse layout, which has the closest aspect ratio to our screen's aspect ratio, and then we can zoom in on the text. And this is something that, this is somewhat like that, what that looks like. And I'll just pop that out in the browser, function 11, and you can, this is kind of changing size on a on-resize event, and you can see as I sort of move it in, you've never got more than more than one blank line at the top and bottom, and there's always two edges which are touching the words, you know, at least one pixel in all of those. And so function 11, and okay, but that gives us a problem as well, because sometimes verses are incredibly short. They might even be a single word like yeah, and we don't want to necessarily emphasize the bridge of a song or something like that. So the end thing I wanted to do was to try and find the largest font we could render the whole song in, and it still work. And the algorithm I've kind of come up for doing that is that you allow n lines for each verse, and then you make the song as narrow as you can, fitting in to those maximum constraint of n lines per verse. You only break the lines that you need to in order to do that, because we want to keep lines as long as possible otherwise. And what's nice about that is you only get one solution for each value of n, so again it kind of works well on a lookup. The next challenge is then zooming in on that text that you've drawn. And so what I do for this, I render everything in a sort of 20 pixel font, and then analyze the pixel data to get the bounds. And I actually draw all the verses on top of each other, which, and then use my kind of canvas get pixels thing to find out the bounds of the whole song when it's rendered onto a certain number of lines. Then I create another canvas which is 110% of the screen size, and I repeat that process, and then I scale it down, and that gives me more accurate measurements, and then I scale it down to the actual screen size, and that gives hopefully a pixel sort of perfect text that fits on the screen. And this is something of what that looks like. Let's see if that's one. Okay, it should be, is there music coming out? Oh.
Code monkey, get up, get coffee. Code monkey, go to job. Code monkey, have boring meeting with boring manager Rob. Rob say code monkey very diligent, but his output stink. His code not functional or elegant. What do code monkey think? Code monkey think maybe manager wanna write nice login page himself. Code monkey not say it out loud. Code monkey not crazy, just proud. Code monkey like Fritos. Code monkey like Tab and Mountain Dew. Code monkey very simple man with big warm fuzzy secret heart. Code monkey like you. Code monkey like you.
Okay, so that's sort of just about the end of this talk. These are some things that I can talk about in discussion track, kind of animating text. You can look at some of the source code. I'd be really interested if there are any Christians who are working on side projects and things like that. I'd just love to meet other Christians kind of working in JavaScript community and things like that. If you're interested in anything to do with design, you can talk to Lelen. If you're interested in putting Chromium web browsers in ATMs, that's what kind of my company NCR is doing, so come and talk to me about that. Another thing I found interesting in this whole kind of project is that we were dynamically creating breakpoints. And so I think this might be interesting for the whole of kind of CSS. We were evaluating thousands and thousands of possible layouts and then trying to choose the best one for the device. And we were doing it with text, which is quite a simple example, but you could probably do it if you were very clever with slideshows and kind of all other things where you want to fit everything on a single display. And so that's kind of quite an interesting area. Thank you very much.